Lesson number 9, demo. In this class, we learn 2 more derivative formulas, the product and quotient rules, and we review the 3 kinds of functions, power, polynomial, and rational functions. Notation reminder, d over dx of something in the brackets means the derivative of what's in the brackets. Number 1, we now expand our collection of derivative rules to include products and quotients of functions. Unfortunately, derivatives of products and quotients aren't as nice as derivatives of sums and differences. We saw those kinds last class. If they were nice, then what would be the answer to this? The derivative of 3x plus 2 over negative 2x minus 1. So I'm going to put here a hopeful equal sign. If things are nice, then maybe I can just take the derivative of the top and completely separately take the derivative of the bottom. And then after I've done those 2 independent derivatives, just divide them in the same order that they are divided initially. And so in that case, the derivative upstairs, derivative of 3x is 3, and the derivative of plus 2 is nothing, divided by, and the derivative downstairs is negative 2. And there is absolutely no chance that the derivative of this complicated curvy function is the simple 3 over negative 2. There's no way that that's true. So unfortunately, things are just not as good with products and quotients as they are with sums and differences. So this hopeful equal sign is a big old no, it just does not work. So the quote rules, the derivative of f times g is maybe equal to the derivative of f times the derivative of g. That's no good. And the one that we just applied is right here, where we just separate over division, and it is simply not true. So let's put some big lines through these things. That's no good. That's no good. Here's the real product rule. Product rule says the derivative of f of x, I'll highlight that in yellow, times g of x, that one's green, is equal to, so it's the derivative, it's f of x copied times the derivative of g of x plus g of x copied times the derivative of f of x. Or in shorter notation with the primes, f times g prime plus g times f prime. So it's fine to learn that in symbols. I also want you to understand it in plain English. So here it is, first times derivative of the second plus second times derivative of the first. That's what it says right here. Thinking of f as the first and g as the second. First times derivative of the second plus second times derivative of the first. So let's apply our product rule to number 4, finding the derivative of this product. I can see the big multiplication symbol right there in the middle. So a product of 2 functions of x says you use the product rule. To be honest, in this one, we could actually do a massive distributive property. 7x to the 4th would distribute to all 3 terms in the second parentheses. Then the 2x to the 3rd would distribute. And then the 5x would distribute. And the minus 1 would distribute. And you just get some big, massive polynomial. And it's totally fine to do that. But honestly, it's simpler to do the product rule. And we're trying to practice with this new rule anyway. So let's try the product rule. So again, in plain English, it says we're doing the first. I'll highlight the first in yellow, and then we'll do the second one in green, just like above. So it says first times derivative of the second. So the first gets copied. 7x to the 4 plus 2x to the 3rd minus 5x minus 1 times the derivative of the second. So what's the derivative of green? 4x squared becomes 8x, minus 3x becomes minus 3, and then that plus 8 disappears. And that is the first part of the product rule. So we've done first times derivative of the second. Now we are doing plus. And now we do kind of the same thing, but in reverse. Second times derivative of the first. So we copy the second, which is green, 4x squared minus 3x plus 8, times, now I don't have room here, so you got to imagine this is times now, the derivative of the first. So that's in yellow. So the derivative of yellow, I see 28x to the 3rd plus 6x squared minus 5. And that's it. That's the end of the calculus for this problem. If you were so inclined, you could distribute now. Whoops, that's not right. Don't pay any attention to that one, but you could distribute the 7x to the 4th and the 2x cubed and the 5x on 1, and you could likewise distribute everything in here through everything in there, group terms, and you would get the same answer that you would have gotten if we had done that massive distributing in the very beginning, but I'm content leaving the answer in that form right there. Okay, the quotient rule is even messier than the product rule. So in the quotient rule, we've got f of x on top and g of x on the bottom, top and bottom, and so I will highlight all of the f's in yellow, f there, only 2 of them. G twice, but then G a 3rd time on the bottom. And so you can look at the symbols if you want, but I know the quotient rule in English. It's right here. thinking of a top function and a bottom function. The quotient rule says the derivative of that quotient is bottom times derivative of the top minus, big difference there from the product rule. This is a minus, the product rule was a plus, minus the top times the derivative of the bottom, all divided by the bottom function squared. So that's thinking of top and bottom. You could likewise also think of these two functions as being high and low. And so if you don't like the thing I've written in bold, you could maybe memorize it this way, where the made up word d stands for derivative. So low d high, low times derivative of the high, minus high d low over low low. So either way, just make sure you can do the quotient rule. Let's apply it here to this function. It's the one that we started the lesson with. Okay, let's find the derivative of this thing and use it to find, and then new notation for us. This symbol here means first find the derivative and then plug in x equals 4 at the end. So in some sense, this thing means if f is the name of the function in the brackets, then this symbol means f prime of 4. So it's just a little bit more awkward to write that using this d over dx notation. F prime of 4 is very compact, but anyway, that's how we write it when we're using the d over dx notation. So here we go. D over dx, this thing here equals, so we're doing the quotient rule, which is a big old fraction. It is really easy to forget that this fraction has, that the quotient rule has a denominator, and so I like to put that denominator first, and that denominator is the bottom function squared. Throw it in parentheses, square it, that way you won't forget it. So on the top in the quotient rule, it says bottom times derivative of the top. So we copy the bottom and we multiply by the derivative of the top. The derivative of 3x plus 2 is just 3. Minus, not plus, but minus the top, copy the top, times the derivative of the bottom. Derivative of the bottom is just negative 2. And so this is a perfectly good final answer for this one, but given that we're about to plug 4 into this thing, it actually is in our best interest to clean this up, to simplify a bit. Before we do that, I want to point out one common mistake. It is really tempting to cross off negative 2x minus 1 with one of the negative 2x minus 1s on the bottom. So maybe this thing would change to a 1, right? You get rid of one of them, and that is simply not allowed. The top is a difference. You cannot simply cross off from one part of the difference without also crossing off on the other part, and there is no negative 2x minus 1 over here anyplace. So it just doesn't work. And the sad thing about the quotient rule is that there is always going to be this temptation, and it always fails. The reason it's always there is because, take a look, there is a green g of x, and on the bottom g of x is being squared, and you will always have the opportunity to cancel. There will always be carbon copies on top and bottom, and you can never cancel. So avoid that temptation. Okay, so we said we were going to clean this up a bit. So again, copying the bottom. No reason to ever distribute out on the bottom of the quotient rule. We'll just leave that in its factored form. But we will distribute on the top. So the 3 distributes, negative 6x minus 3. And then the negative 2 distributes, but also the minus sign. So in my mind, that negative makes this a plus 2 that I'm distributing. So plus 2 distributes through and gives me a plus 6x and a plus 4. And then we'll go ahead and combine like terms. Upstairs, the 6x's cancel, and I'm just left with a 1 on top of negative 2x minus 1. That's thing squared. So there you go. That's the cleanest version of the derivative. And then we will use that to answer the follow-up question, which said find the derivative of, and then we'll copy the thing in the brackets, 3x plus 2 over negative 2x minus 1. And it said take that thing and plug in x equals 4. Oftentimes the x equals is omitted here. If you just see a 4 down there, it means plug 4 in for the only variable that you see. In this case, it's x. Okay, so what does that mean? It means plugging 4 in to that purple derivative there on the top right. So it's a 1 over negative 2 times x, I'll leave a blank there, minus 1 squared. And in this case, the x becomes 4. And so this is now just arithmetic. So 1 over, let's see, negative 8, negative 9, negative 9 gets squared. That becomes a positive 81. So we should get 1 over 81. And that's it. So here in the demo, we are going to actually start number 2 from the group activities. And Actually, let's scratch that. I'll put all of number 2 in the group activities video separate from this one.